if you recall from today's lesson, talking about powers, we had a times b to the power of x. And remember, when we either added or subtracted to the power, it moved it in the opposite direction. Whereas when we added or subtracted this k, it either, if it was positive, it made it go up. If it was negative, it made it go down. So now we're going to kind of explore that with these descriptions down below. Okay, on this first one, notice we're using the graph 2.5 to the power of x. All right, that's this graph right here. It says write the function rules for g of x and h of x based on the descriptions. Then sketch and label the graphs of g of x and h of x on the same coordinate plane. Well, since we're using g of x here, g of x, it's translated to the left 3 units. So remember, that goes into the powers. So if we have 2.5 to the power of x, if it goes 3 units to the left, that means we put the opposite, which is plus 3, in the power. Look at number 2. The graph of h of x is the translation 2 units up. Well, remember, if it's going up or down, then we're going to put 2.5 to the power of x, but this time, since it's up 2 units, we're going to add 2. Notice the difference. This is in the power. This is the constant out by itself. Now you try the next two with number 3 and number 4 to see if you can get the same or get the answer. Now on this section here, we've also combined and added the vertical shrink or a vertical stretch. And we're going to explore that tomorrow in class a little bit more. But in the meantime, what I want to look at is this right here, translated 6 units up. Well, we're using 2 to the power of x. So if you do g of x equals 2 to the power of x, and since it's translated 6 units up, out to the side, we're going to simply put plus 6. On number 6, we'll talk about the stretch by a factor of 5, but I want to go horizontal translation 4 units left, so since this is h of x, still 2 to the power of 5, or sorry, 2 to the power of x, and because we want to go 4 units left, we're going to, in the exponent, we're going to add 4, because it went left, so we want to add 4. Now you try the other two, and again, don't do the factors, we'll do those tomorrow in class. Okay, if you look at number 9, it says a student is told that the graph at the right is a vertical translation of the original function, which is f of x equals 1.5 to the power of x, and determines that the new function is 1.5 to the power of x minus 3 because the y-intercept is negative 3. Explain and correct the error in the student's reasoning. Well, remember what we talked about today. If you have f of x equals 1.5 to the power of x, if you plug in a 0 for x, anything to the 0 power is 1. So if you plug in a 0 for x, that's going to make that 1. So the y-intercept would be 1. So that should be right there. Now, if we have a vertical translation, that means it went down 3. So 1, 2, 3. This is actually where it should cross. Okay? And it says, and determines that the equation must be 1.5x minus 3 because the y-intercept is negative 3. That's not the case. So actually, this is where, if it was 1.5 to the power of x minus 3, this is where it should cross. So we'll talk about how we can come up with the equation based on this information right here. Now, on number 10, 11, 12, it says write an equation of the exponential function whose graph is shown. So we're going to work backwards tomorrow. Remember, it starts here with the y-intercept of 1, and then we go down. So we're going to do some trial and error tomorrow to figure those out. Now, on these graphs, we want to graph the exponential decay function. All right. Now, if you notice, remember what we talked about if I plugged in 0 for x? Well, 1/4 to the 0 power would be 1. And so if you add another 1 to it, that would be 2. So there's going to be a point at 0, 2. Well, what if I go backwards? What if I put a negative 1 right here? What does that look like? Well, I get 1/4 to the power of negative 1. And we just talked about exponents with negatives. Okay, you've got to flip this around. So it'll be 4 to the first, or 4 over 1 to the first power. Now it's a positive exponent, and then we're going to add the 1. So 4 over 1 is 4 to the first power, which is 4, plus 1 is 5. So when we plug in a negative 1 as your x, this is going to equal 5. So we're going to have a point at negative 1, 5. So about right there. Now, if we go a little further, what if I plugged in, since I have negative 1 and 0, well, what if I plugged in a 1? Okay, what if I plugged in a 1 here? What happens? Well, you get 1/4 to the power of 1 plus 1. Well, 1/4 is about 0.25 plus 1, and you get 1.25, or 1 1/4. All right, well, if I go to 1, 1/4 is going to be really small down here. Now, as you notice, if we do 2, 2 is going to be even smaller. So 1/4 squared plus 1. So that's actually 1/16 plus 1. And that's even smaller number. So if you notice, it's going to go, oops, let's go, and it's going to go really close to the x-axis, but it's going to look something like that. It's kind of hard to draw with this iPad, but that's what your graph is going to look like. Now, I want you to practice that and try plugging in some numbers. Start with 0 as your exponent and see what happens. And remember your exponent rules, like this one right here. All right, when you plug in 0 or 1 or 2, start off, like if you have 0.5 here, what will make x minus 2 0? Well, if I plug in 2 for x, so 2 minus 2, then minus 1. So that'd be 0.5 to the power 0, and then minus 1. Anything to the power 0 is 1, and 1 minus 1 is 0. So when x is 2, y will be 0. So when x is positive 2, y is going to be 0. So there's going to be a coordinate point right there. Go through there and just pick out some numbers that would fall within this graph and see what you can come up with.